In this demo, we just show how to set the rate data. Let's say we have these reactions already set up. In fact, the rate data can be entered at the same time as we type in the reactions, or we may set them after we have typed in the reactions. So when we click there, we just come and supply the values here, which corresponds to these values for the rate. So we will supply values such as 1 here, activation energy, any numerical value or numerical formula, which could be a function of concentration as well. So let's say if we supply 80,000 and then we want to use molar fractions as concentration for CO, so we type Y which means molar fractions. So C would means mole concentrations, and then as it's explained here, W would means weight concentration, and then so on. So X would be a weight fraction. So that's how it could be used, and then we can then modify the power law function, which could be also a function that uses molar fractions and instead of mole concentrations. So such as this. So this one will use mole fractions. And then the reactions are by default irreversible. If you want them to be reversible, we select 4 types of reversible reactions. So the information about reversible and irreversible type of reactions can be found inside a help section that contains all the helps that explains how those are being computed. So if you go down here, so it explains us everything related to reversible reactions. So we have 4 types of them. So they are being explained how they work inside the software. So there is a help there inside this tutorial. So this is how one can use and supply the rate data. This can be done with all the reactions inside the software. There are other parameters that we can also set by clicking on parameters and then supplying values for the parameters and then using the parameter as the names is shown here. And then the 3 body functions could also be used in this case. So these are the values. You can set up the JK term as a function here, and then it also could be used inside by following this formula as it is shown here. So this is a simple way to set in the values and then to use them. Thanks a lot. So this one is for the 3 body function. This demo shows how to supply the rate data, which is the pre-exponential constant, the activation energy, the power law formula, and other parameters used to compute the rate. So rate data may be entered as soon as we type in the reactions, or they may be entered later, or they may be read from a file. So let's say we have this reaction. So we can then enter the data here, the pre-exponential constant, so which basically follows this formula here. And we can also select the type of pre-exponential values and then the type of pre-exponential formula. So in this case, we have the Arrhenius form. We can have 2 other forms, which is the sticking form, and then there are 2 of them, and then the formula is being displayed here on the top, and then we can follow this formula to enter the data. Basically, the values that we enter are the blue ones, are the values that we enter. The black ones are built inside the software. So for the Arrhenius type of formula, so we have these blue values to enter. So the pre-exponential function constant, we enter 1 here, we could enter 0.5, and then the activation energy could be a function of concentrations as well. Basically, all these values could be a function of concentrations as well. So if you want it to be a function of mole fraction for the CO, we just type in y of CO. So the explanations for mole fractions and mole concentrations, weight fraction and weight concentrations are displayed here. C means mole concentration, W means weight concentration, Y means mole fraction, X means weight fraction. T is temperature, P is pressure in Pascal, and so on. So this is how we enter them. Now, by default, all the rates are considered to be irreversible. They could be reversible. So there are four types of reversible rates that one may use, or one may just supply any user defined formula in this box here. Basically, any UDF can also be used in this position. So for the types of the meaning of these four types of reversible reactions, we can look in the help section, which describes the four types of reversible rates that one may use. So this is the reverse 1, reverse A2, and then B1, and then reverse B2. So these four are being explained clearly here, so the user may supply the correct value depending on the type of rate being used. So to enter the rate, it's quite handy. And then the rate could be a net rate, or it could be a rate based on one of the reactant or the product. So we may select to tell the software what kind of rate we are entering, so that the proper values could be used. So if it's net rate, again, we can see how the software handles that by looking at this here. So the net rate is this R net, or it could be the rate of each of the reacting component. So it's being shown here, so we know how to deal with it. So the user can enter any type of rate in that box. So that's what it does. The other one is that after we enter that and compile, CKFluidSoft will generate DLL, or dynamic link library, that can be used in C++, Fortran, MATLAB, and even inside Java. So this is what we get from there, and this is how one can use this code to then supply the rate data inside.